Hi guys, welcome to Learn Electronics Repair. I have a board here from the indoor unit of a split air condition system, air conditioner or HVAC. Okay, so this is the PCB, or one of the two PCBs that goes on the indoor unit. The other one's like a little display board. It has an error code on which suggests there's a communication error between the indoor and the outdoor unit. This is the PCB from the outdoor unit, the controller board. I'll link to the video I made, but I've basically checked everything on this. I looked at the communication, which are these optical isolators between the two. It basically powers up on the bench. I hear relays clicking, there's LED flashing. Obviously the microcontroller is awake, alive and kicking, but it just doesn't work. The problem is, I don't know what's wrong, or if anything is even wrong with this board, or for that matter, the other board. An aircon engineer went out and said it's the controller board. He tests things like pressure of the refrigerant and stuff, but whether he tests everything, I honestly can't say. And I'm not actually an aircon engineer myself, I don't go out on site, but I'm happy to look at these PCBs. Also with this one, I removed the EEPROM chip. I can read it and then wrote the contents back with my EEPROM programs, and the chip actually works. One of the problems supposedly that causes these sort of errors is a corrupted EEPROM, but I have no idea if I need the right file contents or if I can actually just erase it and put a blank one in. I tried that on a very similar board to this. It's still powered up with its arrays, but that owner is not on the island at the moment, so I can't honestly say if it made any difference. The guy asked if he could have the boards back, so because I don't know if this is faulty or not, what I'm going to do is check anything obvious that I can think of. But if it's not something obvious, then I'm going to say this is probably at the moment something I can't repair. This type of error, I really would like to investigate this further, but it's time. There's very little information about it. I can see how the communication works with these optoisolators, kind of wired back to back, so one inbound and one outbound. Yeah, you can see that sort of thing. But that's as much as I know. I know the physical way it works. What I don't know is effectively like what's going on a firmware level, okay? If anybody has any good resources to learn that stuff, please put me in the right direction, of course. So, given where I am, let's see if we can figure out what's going on with this board. Let's see what we can test, and then see whether we can actually find anything obvious wrong or not with it. So, how would we go about this sort of repair attempt? What's obvious that we can check? Well, there's a switch here, and we can check the switch. It looks like a reset switch though, but we can easily test the switch. We may be able to check resistors, but generally speaking, resistors burn up if they fail, and usually because something else has failed. Apart from high value resistors and power supply startups, they sometimes just fail. Diodes we should be able to check in circuit quite easily. Optoisolators, again, we should be able to check fairly easily. What's this thing down here? W431, that's a TL431, we can easily check that as well. This looks like some sort of, yes, it's a power supply controller, TNY, tiny something or other, TNY276. I probably can power this board up and see if the power supply is running, okay? And we have something similar, we have another one here. Completely different codes, AQH2223. Let's find a data sheet for that. It looks like a power supply controller because of the missing pin. But what I don't see in this area is a transformer, although here it says transformer out. Okay. Relay Yeah, we should be able to test that. Quite a common failing. Power resistors, we should be able to test those. What's this thing here? Voltage regulator? Maybe. Another optoisolator, says 4 on here. 7805, CW7805. That's a 5 volt positive regulator. We can check the continuity on the wires. I mean, these look fine, but we can. And we can check for any bad soldered joints. This thing is a resonator. It's like a crystal oscillator, really. And on the back, we have a microcontroller, which we can't really test. We have, looks like another EEPROM. I'll have to get the lacquer off, but I'm pretty sure that's an EEPROM. And these are probably, look, you see they connected to these connectors here. So these are probably buffers, drivers, or latches, okay? So let's get a bit of the crap off the back of here. We can see quite a few, well, that's a diode, transistor, or MOSFET, and so on. We can't always test these in circuit, but we can look for any shorts, okay? Same with the 0 ohm resistors. So there's quite a few things here we can just eliminate probably by spending an hour. And after that, well, if we didn't find anything, this may not be something we can repair with the information we have. But let's have a look. Let's do what we can. So, suspected EEPROM just says 4G08, and I can't quite make out the other number at the moment. Okay. Is it worth finding out? Probably not, because we could take it off the board, put it into an EEPROM program and read the contents, write all F's to it, FF, and then write back the original contents and do a verify, and if it passes then the EEPROM is fine. But without knowing if the original contents are any good, does it get us anywhere? Not really. Can we write the original contents to something else? Well, if it's corrupted to start with, doesn't help us. So not much point going further down that route. CPU looks like 95F6 something or other. Can we do anything with it? No, we don't have the firmware. This has its own flash ROM built in, so we can't just replace it. If it's faulty, it's faulty. So no. These things, so these I'm convinced are like some sort of buffers, but all the markings are scraped off these. I don't see anything at all, even without getting the remainder of the lacquer off it. So is it worth doing any more with that? No, because we don't know what they are. Yeah, we can see that they're connected to here, okay, and here, and then this is connected to the buzz. Let's go to the other camera. Okay, so these are connected to the buzz and go into the microcontroller there and there. I'll show you how we might be able to test them, but not knowing what they are, well, if we think one is faulty, we probably can't do anything about it anyway. Okay. So that's all the chips on that side. Chips on the other side. This one we will look up because I'm not sure exactly, but it looks like some sort of power supply driver to me. Switch mode. Like I said, without the transformer. So let's look at that one. AQH2223. Okay, so the AQH2223 is a solid state relay. That's why I don't see a transformer there, because it isn't a power supply, basically. Switch mode power supply, you can see here. It has, yeah, it has 2 triacs in, activated by an LED. Yeah. A 0 crossing detector, so it's only switched when the mains goes through 0. And it looks like, yeah, it either switches pin 8 to 6 or 5. So, yeah, we could test that, but we'd have to test it out of circuit. effectively by lighting the LED and putting in AC voltage with a load here and then see if it switches or not. So we could test it, but I don't see easily in circuit how we test it, okay? Without this thing connected to whatever it connects to. We can certainly check if the LED is okay. So it's a 600 volt without the zero crossing detector. That one, okay. What current does this switch? 9 amps, okay. If these things fail, they normally only fail because the load they are switching is short and they blow up, yeah. But we could test it. We can see that we could test it. We probably have to take it out of circuit to do it easily or safely, okay. So that's that. The other IC, this one, this is a power supply. I know I don't even have to look this up. TMY276 power supply controller. And this will switch the mains. The mains comes in here somewhere. And it obviously generates some power supply voltage. Looking at this kind of like is the isolated part. Yeah, see the transformer runs through there. So that is the main side. There is your large smoothing capacitor, 400 volt loop, 22 microfarads, not very large. Bridge rectifier, your NTC, we can test that. Filters. Power comes in somewhere back here. Yeah. This is your neutral in, N in, it says. And the live in, well, there's a fuse. Which is here. We could just trace from the fuse, see which connector it goes to, and that's the live in. But to test it, you could just apply neutral and just apply live to where the fuse is. Yeah. Oh, in fact, it says there, live in. Oh, it tells you live in. So live in is here. That's this thing, okay? This is the fuse. So that's switching the live out to somewhere. This will be a relay. Yeah, 20 amp, 12 volts, so we can test that thing. And I'm pretty sure one end of this will go to the fuse, but we can trace that through when we get to it, okay? So that's pretty much determined what we can test on this. Let's get on with it. We should try to do this in a fairly methodical fashion. So let's start with the top side first, okay? Resistors. You can't always test these in circuits. Sometimes they won't read correct anyway. It helps also to learn the colour code, guys. You don't want to keep looking these things up. Red, black, orange, or red, black, red. Yeah, red, black, red. 2, 0 and 2 zeros, 2K. And it reads like 1.9. This one is 10K. Reads 10K. So these, because they're all together, these might be in parallel. Looks like they're not. Brown, black, brown, 1, 0 and 1, 0, 100. Reads 99, so they're not in parallel. 100. 100. 1 here, 1, 5 and 1, 0, 150. 149. So they're all reading so far close. Power resistors, definitely check them. So this is, looks like 1, 1 and 3 zeros, 11K. Bit of a strange value that. But yeah, that's what it reads. Move the leg of my camera out of the way for you guys. That's my OCD setting in there. Yeah. Another one. $10K. What's this green thing here? That is, oh, PTC 250. So positive temperature coefficient resistor, probably reads quite well, 2K. Yeah, not particularly low. That's PTC. You would have to see if there's any markings on it. There or not. Oh, there are. 202. So that looks like two zero and two more zeros. 2K, that was like to me a 2K PTC. And what's it read? Yeah, 2.1K. So I'm happy with that. And bear in mind that because it's PTC, positive temperature coefficients, will go up with temperature, the resistance, okay? Another quite big one here. What have we got? 1, 5 and 4 zeros, 150K. Yeah, 146. You see the importance of learning the resistor colour codes and markings, because you imagine every time I have to go and look up those codes, yeah? You're not going to be doing that, you shouldn't be anyway. So learn them, guys. Fuse. Yeah, 0 ohms, so let's just do that way here. Go along here, another resistor. 1, 0 and 4 more zeros. 100K. Yeah, close. You don't have to do resistors first, it's just what I picked on. So that's all the resistors on the top side of the board, and they all read okay. Oh, but there is one more, that's this NTC, so this should read very low really. 16D11 you can look up, but this is going to be a low value. It's to stop too much current when you switch on. The inrush current reads 18, I'm quite happy with that. If they fail, they blow up usually, burn up, yeah, and that's because something else is short. So that's all the resistors I can see on the top side of the board. So I was in ohms range, I'm now going to go to diode range. And let's check all the diodes. So there's 4 in here, this is a bridge rectifier. Okay. Can I see any markings on it? Yeah. Minus AC, AC plus. If you couldn't see, the slope is always the plus. And almost always the AC in the middle. So we can test this. We'll put the red lead on one of the AC terminals. That reads open, but to the positive we should read a diode. There, yeah. Fingers in the way, but it's there, yeah. Odd to get a connection with the fingers not in the way. And again from that one, and then if we go from the negative with the red lead over here on the negative and put the black diode, and we should not see a short across the bridge rectifier. Okay, that reads like a diode. This way. Well, that was in the reverse direction, of course. That reads open. The fact it read like a diode that way, because this polarity never occurs in normal use, I'm not worried about it, okay? It's not short. That's one thing I was looking for. Okay, more diodes. So, diode, all look like diodes. A bigger one here. Diode. That's the TL431. We'll come back to that. Any more diodes? Well, there's diodes in the optoisolator, so we'll do those next. But I see a few more diodes, so diode, diode, diode. So those look okay. So all the diodes on this side look okay. Optoisolators, well, we're in diode mode, so we can at least test the LEDs are okay. So generally speaking, from the dot, this is the anode of the LED, and that's the cathode. If you're not sure, get a data sheet. Okay, but I'm confident enough to say anode, cathode, and this is an infrared LED, so it should read about 1 or 1.05 on my meter. Yeah, 1.01. This one's the other way around up here. Reads a bit lower, but I seem to remember when I was repairing the other ones of these that this one does read lower, and it's because there's a resistor across here somewhere. This is a bit of experience. I've worked on these boards before. Normally you would want to take that out and check it, okay, if it's reading less, but because I've worked on these before, I'm happy enough with that one. We probably can't switch this one on in circuit either. I had exactly the same on the other outdoor units. One more opto up here. Which pins are you? Well, I don't recognise this one. Looks like an optoisolator. What's it read like? Let's see. So, pin 1 would be here where the little arrow is, I would think. Yeah, 1.07. That's an optoisolator. I don't need to go further. Yeah, I could look up the datasheet, of course. Right. So that's all the diodes. Now then. Capacitors. Well, you can't really test these capacitors in circuits, but A, do we expect them to be faulty? Well, they look okay. Yeah, they look like nice and flat. They probably are okay. What you can do though is to see if there's any shorts across any of the capacitors, because we can pretty much assume that a capacitor, no matter what it's doing, should not really short across it. Okay, so if we see any shorts on any of the capacitors, that means we've got a short circuit. Not a short circuit capacitor, but a short circuit on that voltage rail. There's no short there. I'll actually put it into ohms range for this rather than diode range. Actually. Yeah, no short there. Any other ones? Well, there's one up here, which is there. You can see where like the legs are leaning outwards. Yeah, they push them through. So yeah, it's fine. No short on that one. There's a few more down this way. That is marked as a capacitor, that one. I can see one of them is here. I'm not worried about the polarity. I'm just looking for shorts. Yeah. I think this is one of the other ones. 7-8K, no problem. One just below that somewhere. Yeah, there. Okay, that's fine. There's one down here and one up there. Okay, so just thought a joint looked like a bad joint, but it doesn't. I mean, obviously you can look around at all the joints. I'm open to spot something as I go around, because I'm looking around the board. I'm going to do this side anyway. Up here, over that way. Yeah, it's there. It's marked as a capacitor. No short. I'm not going to test all the little capacitors. Probably because they don't tend to fail. What else can we check on this? Well, we can check the relays. And they were, you know, a reasonably common failure, I guess. So let's have a look. So this relay, from what I can see, it has a connection underneath which switches to these two, and then the coil is underneath. So we have one connection over here. Is that the coil? It has like a little symbol in here. Okay, there's one connection here. Let's see what we can see. So if I measure between the two wires on top, these are probably just both open, not connected to anything. Yeah, mega ohm. That one connects to there, and then probably the other one doesn't connect to that. It probably switches between them. Okay, and then we see, yeah, so this is the coil. If it wasn't marked like that, we should be able to test if it's a coil, because it'll have a resistance. Yeah, 158 ohms. That's fine for a coil. This is a 12 volt relay. Okay, so we can actually apply 12 volts across here and test it, because that shouldn't harm the circuit. This would obviously be switched with 12 volts anyway. The question is the polarity. Now, the relay across the coil will have a diode to prevent back EMF, and whichever way the diode doesn't conduct effectively will tell us the positive. So let's have a look. But because of the resistance There we see 120. And there we see 120. So because of the resistance of the coil, I can't actually determine where the diode is. And if I can't see it either, visibly see it, that doesn't seem to go to there. Okay, so I can't really tell which way the polarity is to switch this relay. So to test the relay in this case, I'd be better just to take it out of circuit. What I can see is that's an optoisolator. Yeah, but it doesn't go to here, so yeah, no connection to there. Okay, so in this case, to test that relay, I need to take it out. Let me look at the other one. So there's another relay here. No, that's a capacitor. That's a capacitor. Okay, so there's only one relay. So let's just take the relay off the circuit and let's just check it. We'll try this with braid. If it doesn't come off easily, we'll use a desoldering tool. Okay. Of course, I put the solder in the wrong place. Never mind. No problem. You see that? I warmed one and warmed the other, and this end just lifted out a little bit. This is another way to do it. You see it's moved. Come back to this end. Yeah. So I don't need to, in fact, use the braid or the vacuum tool in this instance. And once it comes off, like so, I can now clean the pads. Ready to put it back on. So I was just pulling gently on it, basically, and just getting two pins hot at the same time. Okay. C, common. In fact, it's marked on here now, but you can see the switch. Okay. Normally open, common. Okay. Not sure what the two on here are for there. Interesting. Okay. Let's see. So polarity doesn't matter. Will the relay switch? Yeah. So that switches between those two. What happens with the other ones that are of interest? So let's go to this one. That's already connected. So that one is connected to that one anyway. And this one switches. Okay. So the red lead and this one basically are both the common, and it switches to this one and to this one, so that's fine. Let's check these optoisolators to see if they actually function. There are a few ways you can do this. I find this probably about the easy. So clip a couple of these little clips onto the optoisolator. On the LED end I'm using. Could do it the other way, depends how you feel. Okay. Put the meter into diode mode. Okay. So this should be the positive end of the optoisolator where the dot is. Positive end of the LED in the optoisolator, I should say. Okay. Just clip the wires on. Yeah. Just over 1 volt, what you'd expect. Now, take another multimeter. We all need more than one multimeter, remember. Ohms range. And measure across the transistor. You'd expect this is probably collector emitter. And it reads 4K, yeah? Now, disconnect this. It's got open. 4K, yeah? Or 41K rather. So, we can see that it switches the transistor, okay? That's probably a good optoisolator. At least we can say it works, okay? This one I think we're going to find it won't do that, like it's faulty, because it doesn't read 1, so there's not enough voltage there to turn the LED on, basically. So this will probably find nothing happens on the output. Capacitor charging, just give it a chance to settle down a little bit. Well, it's not really settling, but let's just disconnect the meter. That's off now yet, this is still climbing up. Reconnect the meter. That makes no difference, okay? That's because we can't get enough voltage into here. I've had that problem with these type of boards before, so we do it a different way. You could use your bench power supply with a resistor, like a 1K resistor or 200 ohms or whatever you fancy, something like that, yeah. Probably 1K is good enough on 5 volts, you could do that way. Well, I use my backlight tester, so this is a switchable one, it's set to 1 milliamp. I connect it to my optoisolator. And this has enough power to drive this, so this should say 1 volt. Switch it on. 1 volt, okay. And we can measure the output in ohms range. About 3K. Switch the backlight tester off. Look, goes up, yeah. Switch it back on. Comes down. So we can say that that is good. You can get these things really cheap on AliExpress, but get the one that has 1 milliamp and 30 milliamps. It's much more useful than the one which just has the 30 milliamps or only says 320 volt. Okay, so may cost you a bit more, but find one that has a switchable current, and then it's very useful for this sort of thing as well as backlight testing. One more optoisolator to test that. This one. Okay, so I've attached the multimeter. Let's get the other multimeter on the output side of it. About 5K. Disconnect the multimeter. Yep, goes up, reconnect it, goes down. So that also works. One more thing on here I can easily test, and that is the TL431. And this is my in-circuit or out-of-circuit TL431 tester, okay? So this one, I put the meter onto volts. I connect my little tester. This is very simple to make, guys. One resistor and just a few pins. I will put the link in the video description. And you can connect it to the TL431 either way round. Okay, we switch the bench power supply on, and this meter will initially just read whatever voltage the bench supply is at, which is 1 volt. So I'm going to just change it up a bit, doesn't really matter, 5 volts, 9 volts, something like that, okay. And then I connect across the TL431, and if it's good, it'll read 2.5 or very close. Yeah, there, 2.499. So that's good. This thing is extremely useful, guys. You've just seen that, yeah? And it doesn't matter which way round you put it, it'll still give you the same reading, 2.5. Okay, so that's everything I can easily test on this side. We're just left with this and the regulator. I'm going to try and power this up. And we have this thing which will have to take off the board to test, okay? Right, let's look on the other side. Start again, resistors. I'm in ohms range again now on the meter, okay. I'm going to test any of the large looking ones. So 100 and 4 more zeros. That's a 1 meg resistor. These things do tend to fail. This will be the startup circuit, I would think. It can read lower. In fact, it looks like they're probably both in parallel actually. Reading about 500k. Yeah, something like that. So those look okay. In fact, I think we can see they probably are in parallel. What else do we have? Well, we have lots of small resistors. Generally speaking, I don't test all of them. I mean, it depends how much time you want to spend, but I would check the 0 ohm resistors because these sometimes fail. Okay. Any more? one here. The value of these are fairly easy to read, by the way. So like 8061 is 8.06k. This will be a very close tolerance resistor. 2001, 200 and one more 0, 2000, 2k. Yeah, which it reads basically. Very close, okay. So if you want, you can test them all, but generally if these things fail, apart from very high value resistors, they tend to just burn up. 5101, so 510 and one more 0, 5.1k. Yeah, so you can go around these things and test as many as you feel like. Okay. I'm going for the zeros and the high value ones. Experience 100k, 10 and 4 more zeros. Shout out if you think I should have tested any particular one. 0. 0, another one. Okay. If a resistor reads lower in circuit than its rated value, that's fine usually. If it reads higher, it's not fine. So 104, 100k. See, that one reads 37, 38k, 40k. Now actually that one has gone up. That reads much higher, about 1.8 meg. Let me just get another multimeter. Now I want to show you something a little bit strange here, guys. Don't let this confuse you. So I've got the multimeter in auto ranging mode, yeah? And if we go across this resistor, which I just put a mark by, you'll notice that it's wired across quite a large capacitor here by the looks of it. So that end goes to the capacitor, and this end goes to the capacitor. If I measure the resistor, you see it's counting 38k, 39k, 4. Then it goes to like 400k and starts coming downwards, and you think it's reading higher than it should. This is some peculiarity with the auto range when the capacitor is charging up. So if I go to kiloohms, tens of kiloohms, hundreds of kiloohms, okay, and measure again, you'll see it's reading higher and coming downwards. Now if I just short out the capacitor, which won't have a lot of voltage in it, it's just a very small voltage from my multimeter, okay, but we short it out and we go again on manual ranging mode. Watch. So it starts very low, climbing up 10k. So it's reading lower than its rated value now, which is quite normal in circuits. The capacitor is charging, and I don't think it'll go crazy now. I think this will just sort of stop somewhere near 100. It may be lower because the capacitor probably has some leakage current, which will show as resistance, and also it goes to something else in the circuit, yeah. But you see, it's not going above 100 now, yeah. So don't let that catch you out when you have auto ranging on ohms range and you're poking around boards and you've got resistors wired across capacitors, okay. Now it looks fine. This capacitor is, yeah, it's this one here. What are you? $470 microfarad, 25 volt. Also, don't make the beginner's mistake. You think these are all 470 ohms. They're not. They're 47 and 0 zeros, which is 47 ohms. They're also in parallel, and they'll read very low. Yeah, about 12.5 or 12 or something like that, 12.4. I just worked out what they were going to be. So don't let that confuse you. 470 is not 470. Right. We could check other resistors on here. If you want, you can test all of them, of course. Always check the big resistors though, especially if they're low value or high, that matter, okay? So We could test all of the resistors, but let's move on to something else so you guys are not sitting here for a very long time. So transistors and diodes. So we want to go to diode mode. Now I don't know if these are single or double diodes, and I don't know if these are MOSFETs or transistors, but I'll tell you what I think as I go along, okay? So diode, D301, it's a diode. Reads like a diode. Reads like a diode. It's not short. These two pins are connected to each other. We can see that. So it's probably a double diode, wide and parallel. This one, Q301. So this will be the base or gate. So we go from here to here. We see a diode junction. Is the same here? Yeah, diode junction to there and there. So this looks like this is the red lead. So black for negative, red for positive, NPN. Yeah, NPN. It looks good, and we can just go between the collector, the emitter with a positive on the collector, which is a normal polarity for an NPN transistor, and the voltage is going up. So that's fine. That's those two. Let's go for another one, see what we have. So this is, again, a MOSFET or a transistor, positive on the base or gate. Looks like a diode junction. Looks like a diode junction. No short. What you can do is you can look at the SMD code, if you can see it, and compare it with the other one. If you find multiple devices with the same SMD code, then you'd expect them to basically read the same in circuit. Bearing in mind there may be other things wired across them, of course. So, transistor or MOSFET. Bipolar transistor, NPN by the looks of it. I could test all the other directions, but I know it's not short and it looks like an NPN transistor. This one looks much the same. Reads lower, but that's base emitter, and you'd probably have a resistor across there. Doesn't read short, that's fine, I think. So go the other way on this one. Reads. No, it's going high now, so it's the wrong polarity. So it looks like, to me, another NPN transistor, probably. This one. Yeah. Like the lower value there, probably a resistor. Probably okay. I think in that direction the reading would go a bit higher, but it's not short. And there's other components around. Another one. Looks like another NPN transistor. Yeah, this the reading's climbing up like I would expect it to do. But I don't see really how that would go faulty in a way that you get a lower reading across here to here than you expect. Yeah, more likely something else in the circuit. This one, what we got? Diode by the looks of it. So diode, and these two are connected together anyway. Now you could connect the other way to make it read kind of like open or higher, but I mean, if you read a diode across it, it ain't short and it ain't open. Yeah, so it's probably not worth measuring the other ones. Transistor, what we got? That reads like a NPN transistor again. Okay, any more? No, I think that's all of them. So they all look okay. These things, now, I don't know what they are, but probably, this is a bit of conjecture. If I assume this is the ground and that's the positive, I don't know exactly where this damn thing. Oh, that says ground. Okay, so if I put the red lead on ground, the wrong way round effectively, and look at these inputs, I'll probably see a diode, and they should all read the same. Yeah. That's because there's a protection diode against reverse polarity inside these chips. And if they all read the same, the chips are probably okay. That reads lower, but obviously it's not short. That reads a bit higher. I'm looking for shorts, really. Or open, yeah. So they probably are probably about as much as I can test them. Okay, if these are faulty, they'll be faulty on this side to the outside world. They probably won't be faulty on this side to the CPU. Okay, probably. So that's all of those components. Everything tests okay that I can test. Bear in mind the stuff that I can't test. The only thing left really is to power it up to see if I have this power supply running and to look at this. Okay, so power it up. Let's see how it's wired. Well, we can see the two AC inputs here. Okay, and that one there comes through the NTC, of course. So don't need that meter anymore. Let's see, continuity. So from here through this inductor here, reads good. Probably a filter or something here, and that goes to here. So this is one mains input here, yeah. Anywhere over here, I think that's probably some terminal block. Yeah, I've got a terminal, spade terminal, so that's one input. And the other input, well, from here through this, so this will be the low resistance. Yeah. Through here to here. That goes down that way. Just trying to find out which terminal it actually goes to. Maybe to one of these plugs. No. Oh, this is the relay. This. Yeah, so this probably goes through the relay. To here. And then from there. Looks like this only switches on when the relay is on, which is strange because something has to power the relay, yeah? But the relay is 12 volts, this looks like a 5 volt supply. Well, what I can do, and there's no reason why I shouldn't do it, just check on these wires. Oh, okay, I've got it. So that goes to the red, okay? So I can connect my mains between the red and the spade terminal here. Right, let's power this up and see if the power supply comes on. Okay, so I have my mains applied between the red wire and the spade terminal. Okay. I've put the current limiting light bulb in because it's always a good idea when you're doing things like this. And we can see that over there, so that's set to limit. I'm going to switch it on. Now, how will I know if the power supply is working? Well, if it doesn't blow up or something, it shouldn't do because of the current limiter. Then, I know this is a 7805. So if I measure between the centre pin and the right hand pin, that's the output of the regulator. And if I see 5 volts here to here, I know the 5 volts is there. And if that's there, everything else is probably okay on the power supply. So let's switch this on and let's watch the light bulb. Well, it didn't. Oh, and the thing bleeped. That made me jump. That was the bleeper on here, yeah? Go again. So it's powered up. It went bleep. That tells me this is probably okay, actually, the 5 volts. 5 volts. Okay, so, and the relay is going click. So this thing is alive. We know that much. The only thing I've not been able to test then is this. And there's possibly also some voltage in the capacitor now. Although because the power supply is running, that should drain away. Well, on the datasheet, it shows us how to test this anyways. So if, for example, we connect live to pin 6 and the load to pin 8 and then the other end of the load to neutral. So this would be live neutral. They're not connected together, by the way. It's just saying voltage for the load. And we light the LED, the light should come on. So let's unsolder this and let's test it. Okay guys, so I've got it connected up. I have the multimeter on the LED, okay. We can see the LED voltage drop there. Switch it on and nothing happens, yeah. I've actually got both light bulbs in series and that one's a lower wattage than this. So that's actually going to come on brighter than this one if it works. So let's just short these together. Both light up. Go back onto here, so pin 6 to pin 8, which is what the datasheet said. It doesn't light up, so this is not switching on. Just disconnect that. Same thing, so this looks like it's not actually working. Yeah, datasheet says 6 to 8. I'll just use my backlight tester instead in case the multimeter can't drive this properly, okay? Drive the LED. I mean, it should be able to because it lights LEDs, so let's take this off here as well. Let's get my backlight tester. Now, I'll just mention, by the way, if you're not comfortable with this sort of thing, then don't do it, okay? I mean, you could, for example, just go and get another one of these and replace it anyway if you suspect it. Although if you're not comfortable with this, you probably really shouldn't be working on this sort of equipment anyway, okay? But whatever is in your comfort zone. Now then, backlight tester. So this is the negative end. This one is the positive end. We can soon see if it's correct because the backlight tester. And we can disconnect the mains to the solid state relay. We can just see if it actually lights up first. So plug the backlight tester in. Okay, should read 1. Yeah, it reads 1. I mean, this is not very accurate, so that's okay. That should light the LED. Let's plug the solid state relay back into the power again. And we try once again. Nothing happens. So guys, we actually have a faulty solid state relay. I'll just double check. I've got a good connection on the breadboard. So from pin 6. Yeah, that's good. So there's no reason why this shouldn't work. We knew this one was good anyway on pin 8 before because it lit up. Yep, that's good as well. So everything there is okay. This should work. Once more. Switch on. 0.8, I mean, this is not accurate. Guys, faulty. AQH2223 connected exactly as the datasheet says. Let's see if I can get some of these because I don't have any. Yeah, I can and they're quite inexpensive. Okay, with free shipping, yeah, no problem. So I'll order some of those and then I'll have to give this back to the customer and we'll find out if this solves the problem, but we have a definite fault there. I hope you enjoyed that. I mean, that is a typical way of tackling this sort of repair. You see, we can't test everything. There are some things we just can't test, or even if we could test them, we can't replace them. So you're not going to find every fault, but you know, spend a bit of time like that and you may kind of get lucky. But I'll be honest with you, the more you do this and the more experience you get at it, the luckier you become. Yeah? Okay? Guys, chat about that down there. And I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now.